Hello, students. We are continuing doing triangle proofs. These are the more fun ones because they're more interesting, more going on. So what do you see in this picture? I see overlapping triangles. Which triangles are overlapping? What else do we see? Does anyone see, oops, I noticed a problem. I had purposefully blanked that out. So I'm gonna put that back as purposely blanked out. I see overlapping triangles. What else do we see? Tired of this. Okay, I see overlapping triangles. What else? How many triangles do you see? How many pairs of triangles do you see? I see these big overlapping triangles. So I'm gonna draw them out separate. I'm gonna draw, nope. Problems with my tools today. Okay, I'm gonna draw that one. That's gonna be F, H, J. And that one is overlapping this one. So K, H, G. I'll draw it this way. K, H, G. And it's good to draw them out separate, especially if your brain has a hard time seeing it. It's good to draw them out separate from each other. It's easier to line up their corresponding parts. Okay. Now let's bring our markings with it. So we had 2 marks from F to L, and then we had 1 more mark from L to J. And same on this side, we had 2 marks from K to L, and then we had another mark to G. What else do we have here? Do you guys see, you see the pair of vertical angles in the middle? You see that? Right there in the middle. We could do like 1 and 2, right? Those are vertical. Angle 1 and angle 2 are vertical angles. Do you guys see these 2 little triangles? Those are cute. Do you think those are congruent? I'm gonna draw my bow tie. I like the bow ties. Whoa, that was poorly drawn. Let me try again. Little cute obtuse triangles, right? Okay. And are those triangles congruent? Yeah, they are. This little triangle FGL is congruent to triangle KJL. Why are those triangles congruent? We remember our list, we have now side angle side, and we have side side side, and we have angle side angle, and we have angle angle side. And we can't use hypotenuse leg for this one because we don't have right triangles. So why are these 2 triangles congruent? We're just playing around with the figure. We're not doing a proof, but if we were, these are things that would be kind of interesting to have noticed. What do we notice? What do we see? Which one do you guys think? Good. This one's a side angle side. So triangles are congruent because of side angle side. Okay. What else do we have here? Okay. One of the keys to notice in a figure where the shapes are overlapping is where do they overlap? And in this problem, they both have angle H. So if I was looking at these 2 big triangles, I would know that it's kind of a freebie that angle H is congruent to itself. So angle H is congruent to angle H. Okay, so that might be helpful to me if I'm trying to prove some triangles are congruent. So I look at that point where they overlap and they both have angle H at the top, so angle H is congruent to angle H, that's a freebie. Somebody pointed out that there's a quadrilateral in this picture. That's kind of interesting. So not really important, but interesting. BHJL, that's the way we would write it, is a quadrilateral. There's a whole chapter on quadrilateral. We may or may not get to do very much with them. Okay, GHJL is a quadrilateral. Happens to be a kite. You can classify quadrilaterals lots of different ways. Do you think there's a way we can get these two triangles to be congruent? We could use segment addition postulate to say that from F to L plus L to J is the same as from K to L and L to G. So we could say these two sides are congruent because of the segment addition postulate. Is there any other? So we only have a side and an angle though, that's not enough. So what if we took something from this pair of triangles onto this pair of triangles? Could we grab something from over here that's on these? Yeah. So since we already know these two triangles are congruent, we could say, I'm going to take angle F. I think I'll use three little guys right here. And I'm going to take angle K. Are those congruent? Is angle F congruent to angle K? Yeah, it is. Because the triangles are congruent, we have corresponding parts of congruent triangles are congruent. Now, if I drew that over here, I drew F congruent to K, then do I have enough information to show these two bigger overlapping triangles are congruent? Yeah, I've got my angle that overlaps by reflexive property. I have these angles, which I pulled off the other triangles because of corresponding parts of congruent triangles. And then I have FG and KG are the same. So what do I have marked for these? So I would be allowed to say these two triangles, triangle FHJ is congruent to triangle KHG. Always want to try to get things in the same order because of angle, angle, side. Cool. If I wanted then to finish it and say that FH was the same size and shape as KH, I could use corresponding parts. Or I could say HJ is the same as HG because of corresponding parts. Or I could even say this angle J here is congruent to this angle G over here. So that's how you just stare at the figure, engage with it, try to pull on things that you remember or know or have learned. All right, let's do this proof. This one's really fun. I'm gonna look at it, I'm gonna stare at it, I'm gonna set up my statements and reasons. All right, what do we see? Wow, there's a whole lot going on. What do we see in this picture? I see two sides maybe of these triangles. Maybe I'll do these in, should we do these in green again? I see two sides of these triangles given. We don't have any angles. Okay. I'm trying to prove, maybe I'll do this in yellow. And I'm trying to prove that angle EGD is congruent to angle EFH. Where's EGD? Angle EGD. That's this angle. I'm trying to, my last step here is going to be that that angle EGD is the same size and shape as angle EFH. Okay. So I'm trying to get those two angles to be the same. Interesting. Okay, what else do you guys see? Let's see if we can get the green. There's so many ways to do this proof, you guys. There's no real right way. I can think of 3 different approaches for this, but I'm gonna roll with the one I started. So do you think, angle D and angle H are the same? Because if they are, couldn't we use side, angle, side? Okay. I think the green triangles are congruent, right? We always have our little thinking bubble. So I think the green triangles are congruent. And I want side, angle, side. Okay, but I'm missing the angles. So is there any way to show that angle D and angle H are the same? I'm gonna give you a hint here. You guys see this triangle? Wow. I'm gonna draw that over here. What kind of triangle is this? Triangle D, E, H. What kind of triangle is that? Oh, there's a giant hint. 2 sides the same, what do we call that? Isosceles. So triangle D is isosceles. What's it mean if we have an isosceles triangle? What's the isosceles triangle theorem? If you don't know, you look back in your notes or you flip back through the book and say, what kinds of things am I allowed to say about isosceles triangles? And one of the main things we're allowed to say about isosceles triangles is that the base angles are congruent. Okay. So that's good. If I can show those are congruent, then I can prove side, angle, side. The green triangles are congruent. What else? I still haven't gotten to these 2 angles. Does anyone see the skinny little gnome hat in here? The gnome hat. I still haven't showed you my gnome. All right, I'll have to find it next time. All right, we'll come back to that. You guys keep thinking. I'm going to start this proof getting to those green triangles. So I'm going to start with a side DF is congruent to side HG. That was given to me. You know what? I'm changing my mind. I want to do the other sides first. I want to do side DE is congruent to side HE, which is given. Then I'm going to point out that we have an isosceles triangle. So triangle DEH is isosceles. That is the definition of isosceles triangle. Okay. Because it's an isosceles triangle, I have angle D is congruent to angle H. Because in our textbook, there's something that says if it's an isosceles triangle, then the base angles are congruent. That's called the isosceles triangle theorem. You could write isosceles triangle theorem here, and I would know what you're talking about, or I would know where to find it in the book. And if someone argues with you, you would say, hey, this is what the isosceles triangle theorem says. And then they'll stop arguing with you because you have shown them a fact, that something that is true. Okay, then I'm going to do line segment DF is congruent to line segment HG. That was also given to me. Okay, let's see what we have. We have a pair of sides. We have the angle included between them, and we have another pair of sides. So that's enough for me to write the green triangles. Triangle DEF is congruent to triangle HEG. Okay, the reason why I showed you, we have a side in common, we have a pair of angles, and we have another pair of sides. All right, so what did that get me? That was good, but why did I do all that? I'll put this in here. I'm still not to these little angles in here. Now, there's really two directions I could go. I could, since I have these two triangles, I could grab these angles off using corresponding parts, and then I could say they're supplementary with these, and then those have to be congruent. But I don't want to do it that way. I want to do it a cooler way. And the cooler way is to say, okay, the green triangles are congruent, right? So all their parts are congruent. So isn't this last side and this last side, aren't they congruent? If the green triangles are congruent, then the third sides are going to match up too. So that's what I'm going to do. I'm going to say, I just told you the triangles are congruent. That means that side EF is congruent to side EG, because those are the ones that match up. Those are the corresponding ones. Corresponding parts of congruent triangles are congruent. Okay, anyone see it? Does anyone know why angle F and angle G, these guys have to be congruent? What kind of triangle is this one? If I draw it out here. What kind of triangle is that, you guys? All right, almost done here. So we got triangle FEG is isosceles. Okay, why? Definition of isosceles triangle. We showed that two of the sides were the same, so that's the definition of isosceles triangle. All right, we did it. Do you see how we did it? Let's write it. Angle EGD is congruent to angle EFH. It's the same kind of reason. If you have an isosceles triangle, then the base angles are congruent. I like this proof because it has some symmetry to it. I get to reuse a reason. Okay, this is a really good one. If you're good with isosceles triangles, this is a really nice one. Very, very beautiful. So if isosceles, base angles are congruent. Okay, that's it. Be good, work hard, keep learning.